2014 question 1, higher level. We'll have a read of the question and we'll have a look at the important words and go from there then. The sketch shows a portion of the roof and external wall of a single story dwelling house. The house has an internal span of 6 meters. The external wall is of timber frame construction with a rendered concrete block outer leaf, a 200mm frame inner leaf and a 60mm insulated service cavity. The roof, which is slated, has prefabricated truss rafters and is pitched at 30 degrees. To a scale of 1 to 10, draw a vertical section through one external wall and one rafter length. Show the typical construction details from 400mm below the ceiling joists through the external wall and the eaves up to ridge level. Include the ventilation path to the roof and 3 courses of slate at eaves. Include 3 typical dimensions of the roof structure. Part B, indicate clearly on the design detailing to ensure airtightness at the junction of the ceiling and the external wall. Right. Now, a couple of important things. Basically, what we have there is an eaves detail of a roof. It's a timber frame wall and a trussed roof. So we'll look at some of the key words. The sketch shows portion of the roof and external wall of a single story dwelling house. Okay, nothing important there. The house has an internal span of 6 meters. That's important, and we'll come to that shortly. Why? The external wall is of timber frame construction. That's very important. So the inner leaf is going to be a timber frame panel. The outer leaf is going to be a solid concrete block wall with rendered concrete block outer leaf. So timber frame construction, we've drawn several of those over the years. We should know roughly the layout of a timber frame wall. Rendered basically just means an external plaster. There's plaster on the outside of the house. A 200mm frame. Now most of the timber frames we've drawn have a 150mm frame. Alright, it's a 200mm frame, so it's quite a big timber frame house, so it's going to be quite a bit of thermal mass on that. And a 60mm insulated service cavity. Alright, that's something we'll draw on at the end. It's something we've touched on a couple of times in the past. A service cavity is something that allows you to drill holes on the inside of the wall. We'll talk about when we come to it. The roof, which is slated, that's important, has prefabricated truss rafters and is pitched at 30 degrees. Okay, 30 degrees, that's important. Prefabricated trusses. For anyone who forgets, there's 2 types of building a roof. There's a traditional cut roof. That is when you cut the roof, all the pieces of wood, the rafters and the joists on site and nail them into place. And the prefabricated truss method is when the trusses are made in the factory and they're delivered and they're fixed. They're lifted up with a crane and fixed into place. When it comes to a timber frame house, it will always be a trussed roof because you can just rest the trusses on top of the timber frame. For anyone who forgets, there are some pictures of truss designs. The most common type of truss design you have in Ireland is a fink truss, and that's the one that we'll usually draw up when we're doing something like this. So it's a trussed roof. Now, you still have a rafter on the truss, you still have a joist on the trough, but you've also got some sort of different structural supports depending on how wide the roof is and so on. That one there is if you want to have an attic in your roof. Alright, but they will depend, the type of truss you use will depend on the width of the roof and things like that. With a truss roof, if you remember when we were drawing things before, a traditional cut roof, the rafter is cut into the wall plate with a bird's mouth. I just want to show you how that is done with a truss roof. If you look closely at this picture here, that's the truss there, that's your wall plate, and your wall is down here. These nail plates, by the way, are used to hold those pieces together. You'll see here, right, the rafter of the truss is not cut in with a bird's mouth to the wall plate. It just rests. So the trusses actually just rest on the wall plate and they're held together with these little ties that are nailed to the truss and nailed to the wall plate. But just when you're drawing this eaves detail, you do not cut the rafter into the wall plate. Now, to a scale of 1 to 10, very important, draw a vertical section through one external wall, so just one external wall, and one rafter length, so the full length of a rafter, show typical construction details from 400 millimeters below the ceiling joists. So it's going to be down here somewhere. Through the external wall, up along there, and eaves, that's your eaves, up to ridge level. That's the ridge. The top of the roof is a ridge. So we have to go right up to there. So our detail is going to go, basically it's going to be that whole part of the roof there. One half of the roof. That's why this 6 meters is important, because we know the full length is 6 meters, half will be 3 meters. Include the ventilation path to the roof and show 3 courses of slates at the eaves. Include 3 typical dimensions of the roof structure. Alright, so essentially we have a timber frame wall, timber frame eaves detail, a rafter going up there, we'll have the joist going across there, and we will also have to include those little structural members on the truss also. We'll start to sketch on that just to kind of get an understanding of how to go about it. Remember what we said before, when you're drawing these details, start where you think the builder would start. Start in a place as if you're building the house. There's the bottom corner of my page. I'll start fairly low and to the left because it's again, just to make sure we always have space. When you're drawing a timber frame wall, I would always start with the timber frame panel first, the inner leaf, because the inner leaf is actually what they put in place first. So a timber frame panel, make sure you leave a bit of space over here for the eaves detail of the roof. I'm actually going to make sure I have an extra bit of space. So timber frame panel, it's said to go 400 millimeters below, so make sure you go up 400 millimeters. When scaled down by 1 to 10, that will be 100. So leave yourself 100 millimeters of space there. The width of the timber frame panel, it's said, is 200, so make sure you make that 200. On the inside of a timber frame panel, we have a service cavity here, so we're going to leave that for the moment. On the outside of the timber frame panel, we have OSB wood or plywood. On the top of the timber frame panel, we have just the head plate. And we have insulation inside the panel there. On the very outside of the timber frame panel, we have breather membrane, which allows moisture to pass out through, any moisture in the plywood to pass out through. And on the inside of the timber frame panel, we have an air tightness layer here. Okay, now usually what we would draw here then is plasterboard in place on this side, but the book says that there's a service cavity. Right, so a service cavity, it says in the question that it is a 60 millimeter service cavity. So what I would do here is I would build out a 50 millimeter batten, one piece of wood nailed up to there. Right, and maybe have one just down at the bottom as well. You can judge how far down that is yourself. Usually it'd be around 400 mil centers, but if, just for the sake of the drawing, if you want to get one in there, you can. And there is where the plasterboard is stuck on. So 50 mil there, and then another 12 mil plasterboard. That will give you your 60 mil service cavity. Now the idea of that is, if you want to drill a hole in here for whatever reason, hang a picture or put up some wires or whatever, you're not penetrating the air tightness layer, so you're not compromising the air tightness of the house. That's why you have a service cavity. Service cavities always have some extra insulation in there as well. So it's basically a couple of battens sticking up and then plasterboard over, and they can plasterboard onto that. All right, now we have the external leaf. I'm going to draw the external leaf. So there's always a 50 mil cavity, by the way. External leaf is blocks. Again, everything to be drawn lightly first of all. I'm going to draw it lightly first as well, just because the roof might be coming down over it. But there's the external leaf, and draw your blocks in if you want. Now we're going to start drawing the roof. We said it's a prefabricated truss roof. On top of this we have a wall plate. A wall plate with a timber frame roof is just a little bit smaller than a normal roof. It's just another head plate on top there. That's 50 millimeters by 200 in this case. All right, now next we're going to have the truss resting on top of that. So we have to draw half of the roof. So we want to know how far across here we have to go as well. The question said that the whole roof is 600 millimeters. The internal span, that's the inside of the wall to the inside of the other wall. So to get halfway, that will obviously be 3 meters. When we scale it down, it's 300 millimeters. So you'll measure across here your 300 millimeters and just draw a light line up there. So you know that's how far across you have to go for your drawing. Alright, now at this point I would lightly draw across the space for a joist. Extend that on for the moment. Alright, the pitch of the roof, the question tells us, is 30 degrees, so you're going to go up here. Now remember, it does not cut into the wall plate, the truss just rests down on top of the wall plate when it comes to a truss roof. So go off at your 30 degrees. There. You can see it cuts into the wall of my sketch a little bit here. I think in the actual solution it doesn't, but I'll rub that out anyway. If you want to make this your wall go a little bit lower there, that's fine. Okay, so we have the position of that now. Those trusses and rafters are always 150, so we'll go out our 150 here. Extend that on. Up there. Bring it back down here. How far down here you can decide yourself. Somewhere enough so you can fit a fascia and a soffit and a gutter in. And we have 150 millimeters here, so run that across like that. Alright, now you can rub out a few of these bits. This piece of wood is held onto that piece of wood by what's called a nail plate. So it was that silver thing that I showed you. It's got a lot of kind of spikes in it, and they're just hammered, and these are all made using machines. You can shade that in with silver. Now when it comes to drawing those structural members of the roof, we're going to go for a fink truss. It's the most common one. Look, you don't need to overthink it. Just come up maybe even enough space up here. Get your 60-degree set square. Alright, and draw a 60-degree angle roughly like that. Go across 150. Do your next piece. Okay, this needs to go up to the center also. Generally speaking, this piece, you know, pick a point and have that drawn like that. Again, don't overthink sizes of that. Just get that shape. That's the way they're cut. There'll be a nail plate put there, and then this goes off up towards the center, like that. All right, and that piece is like that there. And again, you know, there'll be another one. We don't need to draw for this, but just for the sake of understanding, another one will go down like that. And your rafter will go off like that. And you'd have that structure going down like that. Now there's a nail plate that goes into place like this. They have a bigger nail plate for these top pieces. Again, just simply look it up on Google if you want to get that understanding. That is there. And there'll also be a nail plate covering these three pieces here, which fixes it into place. There's a nail plate on both sides of those. Okay, so don't worry too much about angles and positions. If you get it roughly like that, you're going to be spot on. Then we come over here. We have to get our soffit and fascia and slates. So again, how far down here do we go? You make a judgment yourself. 25 mil fascia. It goes a little bit above the rafter. Come down there, a little bit below. 12 mil soffit. Coming along there. Alright, there's a vent here. The question specifically asks you to show the ventilation path, which we'll show in a minute with a ventilator. Make maybe a 60 or 100 millimeter vent there, you can decide. Tilting fillet here. Alright, now again, slates, tricky. A 700 millimeter is the standard size for a slate, so our battens are going to be half of that, 350 apart. From this point, I measure 35. Draw a batten, 50 by 35. From the front of that batten, I measure on 35 again, and I go up 50 by 35. So here to here is 35, and then on 50. One more, it asks for 3 courses of slates. Here on 35, and then move on 50 from there. This very, very front one, there needs to be 3 slates overlapping here, so you put a batten in between the middle there. 50 by 35. So how far is this one? Just half. This batten is halfway between here and here. So a quarter of a slate they cut first, and that rests down over. Half a slate here. Again, try and make it, now this is a bit untidy, try and make it so we have straight first of all, and you have a slight gap. That's not a great effort there, but to have a slight gap in between those. Make sure that comes down past over there, by the way. And then your last one should come, this takes practice, over there. Now again, that's quite untidy there. It should be neater, you'll see in the solution. And then I do another one, a full slate from the center of this all the way down. Now if you have to go a little bit above 700mm with your slate, that's fine to make it work. That's too much of a gap there. Okay, that's the slates. The ventilation, it asks specifically for, there's insulation, by the way, is going to be all the way along here. I'll just do that quick enough. That'll go and that'll run in here. There'll be a cavity closer on top of that, which I've left out also. Now the ventilation can sometimes get blocked by this insulation, so we put our eaves ventilator in there. We've looked at that several times last year. Eaves ventilator into position there. Again, where does it go exactly? Make sure that it's before this insulation and after it, so it can carry air over that insulation. Usually 600 or 700mm long for an eaves ventilator. It shows so clearly the path of air, so a couple of arrows if you want to show that. If you want, it doesn't ask specifically, but sometimes insulation goes up along here. You can add that, or sometimes there could be a second layer of insulation on top of that. You can add that if you like. It doesn't ask specifically for it, but you can add that in if you like. I've just noticed my service cavity that actually needs to go right to the top. So let me put that batten up there, and that's the majority of it done. Part B, it asks to show how it's airtight at the ceiling and the wall, so how no air is stopped from leaking out through this junction here. What you would do is you could put some plasterboard on the ceiling. Nowadays usually the plasterboard is insulated, so if you want to make a 50mm plasterboard you could. That is plasterboard there, and that's all insulation. It'll usually be rigid insulation, but you can just put that'll do fine. Now, how do we stop air from leaking out through this part here? Well, first of all, you have your air tightness membrane, that red line along there. Okay, but to stop air from sneaking out past that, you would have air tightness tape in the corner. It's taping the junction, so no air can escape out through there. And with a roof like that, you would need an air tightness membrane along the top there as well. So there's air tightness membrane along the top of that. Okay, so that's the general order as to how it's done. We'll have a look at the actual solution. I'll talk through any aspects of that that need to be looked at as well. Now, there's the full detail. It works up quite big on the page once you get the detail in. Here, over to here is 300. You can see the timber frame panel. There's my service cavity. I put some battens into that along there. You have your air tightness tape in green here to make sure no air escapes out. Air tightness tape is used, the junction between the wall and the ceiling. There's the path of air getting up through here. I have a second layer of insulation going across now. That usually goes all the way across, but you're just showing there that it's on it. If you want to extend it on, you can. There's the slates, a little bit neater looking. And I have a gutter, which I keep forgetting to add on in my sketches there as well. Freehand that in. Okay, so have a look at that and see how the question goes.